making this video today to demonstrate completing this square. If we've got a quadratic equation, most quadratic equations are as ax squared plus bx plus c equals 0. The a is called the lead coefficient, c is usually your number on the end, it's a constant, and b is your x to the first term. These are in descending order. So this is normally how we would see a quadratic. Now, to complete the square, here are some of the steps that have to be followed in order to do that. The first thing you're going to want to do, now there are a couple of ways to do this, but just to keep it simple for now, what you want to do is you want the c on the other side of the equal sign. So what we're going to do is we're going to basically subtract c's from both sides. So the first thing you want to do is get your ax squared and your bx on the left-hand side of the equal sign and put your c on the right-hand side of the equal sign. Now c is just a number. It could be positive, negative, I don't know, I don't care. It doesn't matter. You can put plus or c or minus c or whatever. But you just want to take the number and put it on the right-hand side of the equal sign. You're going to want to leave some space here also in order to complete the square. Now for step 2, here's kind of the conditions that have to be met in order to complete the square. One condition is that the coefficient in front of the squared term has to be a 1. If the coefficient in front of the x squared term is not a 1, you've got problems. You're going to have to divide every single term by whatever a is so that you force it to become a 1, because you can't complete the square if there's not a 1 in front of the squared term. So this is a must-have. Now if you've already got a equals 1, then you can skip this step and go to step 3. What you're going to do is you're going to take half of b term. Now in mathematics, I just want to point out, the word of in math means to multiply. So if you take half of a number, you're taking half times whatever b is. You're going to want to square it, and you're going to add it, to both sides of your equation. What this does, by taking half of b, squaring it, and adding it to both sides, what it does is it makes this thing called a perfect trinomial square. What's a perfect trinomial square, you ask? If I had x squared minus 6x plus 9 equals 0, and I want to factor that guy, if I factor him, please note that he factors x minus 3, x minus 3. That's how we get the plus 9. Remember, first, outer, inner, last. Inner is going to be the minus 3x. Outer is going to be minus 3x. That's where the minus 6x comes from. Minus 3 times minus 3 plus 9. This is a perfect trinomial square because both of these binomials are the same thing. In other words, x minus 3 quantity squared equals 0. And this is called a perfect trinomial square. Now, whenever we have a perfect trinomial square set equal to some number, we can use what is called the square root property. So you're going to want to write, once you take half of b square and add it to both sides, you're going to want to write the left-hand side as a trinomial square, x minus half of b squared, and set it equal to whatever c is. So you're going to want to write the left-hand side as this perfect trinomial square. Okay, so let's see this in action. How do I solve by completing the square? Well, this first problem is actually very nice to set up because we don't have to do anything. In fact, we've already got the 8 on the right-hand side of the equal sign. We've already got a 1 in front of our square term. So we're actually skipping step 1, skipping step 2, and going directly to step 3. Now I'm going to rewrite this so that I have some space and do this. Now, in order to complete the square, what I want to do is I want to take half of 2. Now, if you have to write this out on scrap paper, half of 2, that's going to be, and it's actually half of negative 2, by the way, because that actually is a negative 2. Don't really care that it's negative because I'm going to square it, so whatever sign it is, I'm going to square. It's going to be positive anyway, but whatever. So 1/2 of negative 2, or 1/2 times negative 2 over 1, is going to give me a negative 1. Negative 1 squared is 1. So half of 2 is negative 1. Negative 1 squared is 1, so I'm going to add 1 to both sides. What this does on the left-hand side is it creates a perfect trinomial square. Please notice that this will now factor into x minus 1 times x minus 1. 8 plus 1 is 9. Now, the square root property from intermediate algebra tells us that we're allowed to take the square root of both sides. So I'll come in here, square root both sides. Don't forget your plus or minus symbol. This comes out as x minus 1 equals plus or minus 3. I'm going to add the 1 to both sides. So x equals 1 plus or minus 3. Now since 3 is an integer and 1 is an integer, I can actually figure out what x is. X actually equals 1 plus 3, which is 4, and 1 minus 3, which is negative 2. And there's my answer. And this is a process of completing the square. Now this example is the most simple. It would have factored, but remember, what I'm saying is if I didn't, there are factors of 8 that add up to 2, and they would be negative 4 and positive 2, and I could have factored that. That's not the point of the exercise. The point of the exercise is to solve by squaring the square, which is what we did. So this was kind of a simple problem. Let's move on to a more difficult problem. First thing we have to do is we want to get it in this format. We want to take this number and we want it on the other side of the equation. What I'm going to do to do that is balance my equation, and I'm actually going to subtract 22 from both sides. So I'm going to get y squared plus 10y. Leave yourself some space, put your equal sign, and it equals negative 22. Now, we're ready to do step 3. Why did I skip step 2? Because I already have a coefficient of a 1 in front of the y squared. So I'm going to take half of 10. Half of 10 happens to be 5. 5 squared is 25. So I'm going to add 25 to both sides of my equation. And now you'll notice this guy right here, he will factor into y plus 5, and this will be a 3. So what I'm going to do now is, again, I'm going to use the square root property. I'm going to use the square root property, take the square root of both sides. Y plus 5 equals, don't forget that plus or minus sign, plus or minus square root of 3. I don't want to turn that into a decimal. I want an exact answer. I'm going to leave it. Then I'm going to come over here, and I'm going to subtract 5 from both sides. And I'm going to say y equal negative 5 plus or minus the square root of 3. It would have taken twice as long if I had used a quadratic formula here. You've got a coefficient of 1 in front of the squared term, and you have an even number for b in front of the y to the first term, or the x to the first term, then you know that this is perfectly set up for completing the square, way faster than using quadratic formula. So this is a process of completing the square. Let's move on to a little bit more difficult problem, and that's going to be this guy down here, this number 3. Why is he more difficult? There's a 1 in front of the squared term, so that should be good. Yes, it is. That's great. But look at my b. My b now all of a sudden is not a number like it was in these other two problems. My b is now 5. Well, how do I take half of 5? Well, that's where fractions come into play. So we're going to say y squared minus 5y equal to, remember, we're adding 2 to both sides. Now, how do I take half of 5? Half of, remember, of means to multiply, half of negative 5 over 1 is actually negative 5 halves. Ooh, well that doesn't look very pretty. No, it's not very pretty, but it will work. So half of negative 5 is negative 5 halves. Negative 5 halves, quantity squared, is in fact 25 fourths. So what I'm going to do is I'm going to add 25 over 4 to both sides of my equation. Now, up here it says whenever you complete the square and you take half squared and add it to both sides, when this factors out, you're actually going to use the 5 halves. And so since it's a negative 5 in the inner outer term, this is going to factor out into y minus 5 halves quantity squared equals. Now we've got a problem. We've got a 2 plus a 25 fourths. I can't add those if I don't have a common denominator. So what I'm going to do is I'm going to have to multiply 2 by 4 over 4, which is actually a 1, just to get him into a common denominator. So 2 times 4 over 4 is going to be 8 fourths. So 8 fourths plus 25 fourths is 33 fourths. Now that I've done that, I am ready to take the square root of both sides. So we get y minus 5 halves equals, don't forget your plus or minus sign, plus or minus, and by the way, the square root of 4 is 2, so I could rewrite this as the square root of 33 over 2. Now I'm going to add my 5/2. Remember, it goes in front of the plus or minus symbol, so I'm going to add 5/2 to both sides, and I'm going to have my final answer. Y equal 5/2 plus or minus the square root of 33 over 2. And I've got my answer. So this is completing this square. A couple more problems on this page, but to keep it simple, keep it short, this is a demonstration of how you would complete this square. In college algebra, what you're going to be doing is making sure that you're going from ax squared plus bx plus c equals 0, or equal y, or y equal ax squared plus bx plus c, and you want to turn this into y equals a times x minus h squared plus k. It's the same process, it's just that this is the format you want to put it in. That's all for now. Hope this helps. Thanks.